So good afternoon, everyone, and welcome to this series of webinar. Today we have the last webinar, which is the 7th webinar, and we have been, as you know, initiating this series of webinar from the month of September. If you go to the next slide, Darshana. So we had these different schedule, as you can see from the slide. We started on the first webinar, which happened on the 18th of September on the panel discussion on fundamentals of hydrodiplomacy, which was actually a discussion mostly around setting the context of the series of webinar that we have been hosting. The first webinar we had was on the 25th September, where we had Professor Roger Falconer, who is the Emeritus Professor of Water Management in the School of Engineering at Cardiff University. In this particular session, we discussed mostly about what water security and integrated modeling studies. And he mostly discussed about, like how water security and diplomacy are linked and why we really need a holistic approach to manage water resources. Then we had the webinar on power in hydrodiplomacy. Here, the discussion was mostly about that how power can shape negotiations, how power can bring in, change the narratives around the discussion. And it was also felt that although there is so much role power play in policymaking processes and outcomes, in research and in literature, it is still not very well highlighted. So hence, there is a research gap which needs to be understood. And then we had the next webinar on communication and media. Here, the focus was on media, which is considered to be one of the very important stakeholder on hydrodiplomacy. The idea here was that, how can we bridge the gap that exists between media and science? How can scientific community provide the necessary inputs to the media? And how media can play a significant role in bringing the right kind of discussions, dialogues around a transboundary river basin. Then we had a webinar on hydrodiplomacy and gender. Here, we tried to understand that when we talk about hydrodiplomacy and stakeholders, do we need to distinguish between the kind of stakeholders we are dealing with? Can we also look at the role that men and women play in the hydrodiplomacy? And again, it was felt that the role of women in hydrodiplomacy is still at a very, very nascent stage. And so a lot of research, success stories, role models needs to be, we need to bring it up more. And also the role academic institutions can actually play to bring in many more women water diplomats. Then the next session was on transboundary water conflict and cooperation. Here we tried to understand that it is no longer that conflicts and cooperations are on two opposite ends. It was through several case studies, it was highlighted that in several river basins where there are conflicts, but cooperation is also happening simultaneously. So it is not that if two countries are not in very good terms, it doesn't mean that they cannot work together when it is about water. Then we had a very interesting session on understanding international water laws, how they operate, what are the structures, how flexible are these water laws, and also how international water laws can actually motivate countries to engage with each other and to manage their disputes. And the last hydrodiplomacy webinar was on mediation, dispute resolution, and conflict management. Here, a lot of practical experiences were shared by two very eminent people who actually have worked very closely in different river basins. And even Indus River Basin was highlighted. And again, here, mainly we saw that, while water is a driver of conflict, it can also become a catalyst for cooperation. And today we have the 7th webinar, and the title of today's webinar is Water Scarcity to Security through Sustainable Solutions. And we are really very delighted to have Professor T.G. Sitharam, who is the director of IIT Guwahati. Professor Sitharam also addressed this whole webinar on the first day when we had the inception webinar. He delivered a keynote address, and we felt that it is an excellent opportunity for us to bring him back on the day when we are ending the series of webinar, so that we can get his views on the subject. So many of you already know Professor Sitharam, but let me just very quickly introduce him for those who are joining the webinar for the first time. He's the director of IIT Guwahati and a professor in the Department of Civil Engineering. He also holds a position of senior professor in the Department of Civil Engineering in IISc Bangalore. He was formerly a chair professor in the area of energy and mechanical sciences at IISc, and also a former founder chairman of Center for Infrastructure, Sustainable Transport and Urban Planning at IISc. And in 2015, Professor Sitharam received the prestigious IGS Kukulman Award for his lifetime contributions in the field of geotechnical engineering. Thank you very much, sir, for joining us today. Our discussant today is Professor A.K. Sharma. He is a professor in the Department of Civil Engineering in the Indian Institute of Technology, Guwahati, and a visiting professor of Asian Institute of Technology in Thailand. Professor Sharma was honored with the prestigious B.P. Chaliha Chair Professor position by the Ministry of Water Resources, Government of India between 2009 and 2018. Professor Sharma is a member of several high-level national committees formed by Government of India, and he has provided his technical expertise for the management of water resources in India as well as abroad. Some of the examples at some of the river basin with which he has worked closely are Brahmaputra, Ganges, and Mekong. And he also works on several water-related issues within the northeastern region of India, where IIT Guwahati is also hosted in Assam. So with this, I would like to welcome both the speakers once again, and I'm going to hand it over to Professor Arup Sharma to take the session forward. Thank you.
Thank you, Anamika, and welcome all the participants to this particular talk, today's talk, as already introduced. Under this hydrodiplomacy, today's talk is on water scarcity to security through sustainable solution. Now, when we look into this particular topic itself, like say water scarcity, now this term is not very new, not very old. It is very recently it is becoming more concerned. Because if you see that from our childhood, when we were taught in our school, that if we consider the entire globe, then this 2/3 of the globe is covered with water and only 1/3 is land. So because of that, so far, most of the fighting, claiming, and all these things are happening for the land. But recently people are realizing that no, water, which is an elixir of life, is a scarce commodity. That feeling is coming. Why? Because if 2/3 of what the whole globe is filled with water, then why this feeling is? Because first point is that, of course, that 97.4% of that water remains in the ocean, and when it is in the ocean, then the saline water, it is not of that much of use for us, and the process is very costly if we want to use that. And the fresh water is only 2.6% around. Now, when we see that whether this 2.6% of water is sufficient for us, for the human being, for the nature, then if we look from like water footprint point of view, then that water footprint per capita per year that was estimated, this is also around 1240 meter cube per capita per year. Now, if we look into this per day, it will come to around 3.4 meter cube. So if we look into the total available water and then this number, this also is well under manageable condition. So the major concern, what is happening is the spatio-temporal variability of the fresh water. So that is what is the major problem. If we see the Indian context, suppose, if I just look into the Indian context, then you see the northeastern part of India where Cherrapunji is also there, and there the rainfall precipitation, which is the first freshwater input to the globe, it goes to about 14,000 millimeter, as high as like this. Average is being 11,000 here in Cherrapunji. So then when we go to the west in Rajasthan, in some area, worse condition, it comes down to even 200 to 300 millimeter of precipitation annually. So this is the spatial variation, but more importantly, the temporal variation. Even when we have water, suppose the monsoonal water when we have in this part of our country, suppose the northeastern part, if I give you as an example, here you see that within 4 to 5 months, almost 70 to 80% of the water comes, and then utilization becomes difficult. So this is the reason, if we provide lots of food to you in one day, you will not be able to consume, and if you try to consume, there will be problem. But if you give storage, a refrigerator, if we give, then you will be able to store it and use it. So situation is almost similar. And with the impact of climate change, the temporal variation is increasing. Our studies have shown that high intensity precipitation will be becoming more and more with longer dry spell. That means there will be more flood, expected more flood and more drought situation. And also because of our human activities like deforestation, then urbanization, which are need, of course, because of this, what is happening when the precipitation is falling, with deforestation and with paving of the surface because of urbanization and various activities, the infiltration to the ground is reducing. We are also filling up the all low-lying areas like bill or man-made ponds also we are filling up because of the demand of land. And that's why we are increasing this temporal variability. All this water is moving quickly to the river, causing flood and moving, damaging all things and moving to the sea. And when it goes to the sea, it becomes useless. So now we need to increase the storage. This can be one solution. Now we are very lucky that today we have with us Professor T.G. Sitharam, already introduced by Dr. Anamika. Professor Anamika has introduced. And we are very lucky that he has in-depth study on, first, of course, the sustainable goal, sustainable development goal, what it says and how it helps and how water is involved in all these points is extensively studied. And then water scenario, actual scenario of the water, how much percentage is where, this also he has very in-depth knowledge on that. And more importantly, he has thrown a lot of innovative idea to overcome this water scarcity, so-called water scarcity, because actually if we count the number, there is no scarcity, but because of spatiotemporal variation, the scarcity is arising, and how we can take measures, innovative solution, innovative idea for getting a solution to that, how we can make water security, bring water security to all. So with this very introduction, let us now move to Professor T.G. Sitharam. You are all waiting for him. Then again, during discussion, I'll be coming back. So now may I request Professor T.G. Sitharam, Director of IIT Guwahati, to deliver his talk on this very important issue. Thank you very much. Thank you all.
Thank you. Thank you, Anamika, for introducing me. Thank you, Professor Arup Kumar Sarma, for giving a very nice overview about the water, the issue of water. So as you all know, and you all agree, water is very critical to all of us. And this water, we would like to save for the future. Because, as I told you, as even Arup Sharma was explaining to you, the water stress, the word, has caused a lot of disruptions, has caused countries around the world to consider ways to mitigate the impact. This is basically caused by the population growth as well as climate change. So these are the two factors, the increase in population and the climate change. So the Global Risk Perception Survey conducted among 900 recognized experts by the World Economic Forum reports that the highest level of societal impact over the next 10 years will be from the water crisis. You have also heard from different experts there will be a next war, if any world war is going to happen around water war. So today, my topic I've selected is water scarcity to security. I will highlight to you what is the term scarcity. Professor Arup Sharma actually gave you a good answer already to the scarcity issue. And how do we really achieve the security? And what are the kind of solutions? And particularly with respect to the water, we need to look at the sustainable solution so that we meet the sustainable development goals. I'm going to talk to you about SDG goals as well. So here, most of my solutions, what I'm going to talk to you is about what we call is innovation with the nature, okay? Which are basically what is called as nature-based solutions. Today's talk, I have given you the agenda of the talk. I'm going to briefly touch upon the goals, SDG goals, with what are the challenges of this water. And then I will take you through India's water resources, how are we placed, and what are the traditional water harvesting structures. Because India is one country, lived for 5,000 years or more, with a lot of innovations and very vibrant society, okay, from the beginning. So we are the first one to teach the whole world how to build cities, how to give water supply system to every house, okay. They are one of the earliest, Harappa Mohenjo-daro. If you look at the civilizations, there itself they already started looking at water supply systems to every house. That concept was there. But even in 2020, in the 21st century, we still were not able to achieve it, particularly in the last 150 to 200 years. So it is so much become a problem of water is such a issue in every village and town of the country. So with the target of 5 trillion economy, our Honorable Prime Minister has put it up for us by 2024. And looking at the COVID-19 affected time as well, it is necessary to think very big when seeking to make a difference for transformation which does not come from modest plans. So we need to look at some big plans, and water is the one key issue. So the mission water would play a major role for India. So we as scientists and researchers together should start thinking about where did we go wrong and how do we really solve the issue of water. So India being a village-centric economy, how many villages? More than 6 lakh villages, and lot of the MSME sector are moving to the outskirts of the towns and our cities. In that conditions, large number of people also, I mean, density of the population of per square kilometer is so high in India. So large number of people are also moving back to villages now. I mean, you have witnessed during the pandemic. And if you look at the 6 lakh villages, so we need to, if you want to really empower the economy, then it can only happen if water is taken as a mission. So when water is available at plenty, so there are many problems we can solve, whether it is industry or agriculture or food. So this nexus of water, energy, food nexus is in play, and water is critical to all of that. So on January 1st of 2016, Sustainable Development Goals, 17 goals, which is listed here, as an agenda, set up in the United Nations in a historic summit in 2015 actually, but the 1st January 2016, this was adopted by the world leaders sometime in September 2015, but I came into action from 1st January 2016. And the goals are these. So that is no poverty, zero hunger. So I can go on. But if you look at the goal 6, water. And also one more point, water is actually part of most of the goals, SDG goals. To alleviate most of these goals are to do solve this, most of the goals, water plays an important role, and particularly on the clean water and sanitation, that is the goal number 6. What is the goal number 6 is ensure availability and sustainable management of this water and sanitation for all. India has taken this big step. So not only India, all member states decided on a single SDG goal for water and sanitation that looks at the entire water cycle from the resource to services and back to the resource. This is what I made it very clear to you. When you're thinking from water as a resource and also to services and back to the resource, that means it's basically a circular economy around water. And if you want to really achieve 5 trillion economy, as our Honorable Prime Minister wish, in another 5 years, so we need to think big on mission water. The decision of the member states of the United Nations is informed by the fact that all aspects of water touch on human development, and none should be looked at it in complete isolation. So total of the 8 targets in this goal 6, there are totally 8 targets and 11 indicators under SDG goal 6. Bearing this in mind, we will now focus closer on target 6.1, that is drinking water, okay, and then 6.3 is water quality, and then 6.5 water resources management, and also touch upon some of the ecosystems, because I'm talking about sustainable solutions and water use efficiency. So sanitation and hygiene is one aspect I don't touch too much today in this talk. So coming to the sustainable development goals, as I told you, each goal is important out of the 17, but water is very critical, as I told you, that is number 6, SDG goal 6, measures to overcome water shortage. So we need to move from shortage to security, okay, or scarcity to security. So to do this, the sustainable development goals are basically an universal call to action to end poverty, protect the planet, and ensure that all people enjoy peace and prosperity. So what is this new in this SDG goals? First and most important is these goals apply to every nation and every sector, cities, businesses, schools, organizations, all are challenged to act. This is called universality. Second, it is recognized that the goals are all interconnected in a system. We cannot aim to achieve just one goal, we must achieve them all. This is called integration. And finally, it is widely recognized that achieving these goals involves making very big fundamental changes in how we live on Earth. This is called transformation. So universality, integration, transformation. So what is the role of the member states? The role of the member states is United Nations encourage all member states to develop as soon as practicable, ambitious national responses to the overall implementation of this agenda. This can support the transition to the sustainable development goals and build on existing planning instruments, such as the national development and sustainable development strategies as appropriate. So it's also to be noted, member states to conduct regular and inclusive reviews of progress at the national and subnational levels, which are country-led and country-driven. That means each country has the freedom to do what they would like to do to meet this. Such reviews should draw on contributions from indigenous people, civil society, private sector, and other stakeholders in line with national circumstances, policies, and priorities. National parliaments also, as well as other institutions, also can support these processes. After saying that, I would like to say that today, in today's talk, I have drawn many things from the recent report by the United Nations Water, UN Water. UN Water has brought out a new report, WD, developmental report in 2020. So you can actually Google it and download that. It's a very interesting document. So in that, what it says is what the challenges are, they have been divided into 3 sectors: availability, quality, and accessibility. See, please note this. This is where, you know, when you define water stress or water availability, so these are the 3 points which you have to say. Availability, are we really short of water? I think there is no shortage of water, as I told you before, and even in my talk on the first day of the inception, very briefly I gave a talk on that day, and I told you there is no shortage of water. But quality, accessibility are the issues. Quality, accessibility. That means we need to plan. Even our civilization knew that India gets only 4 months of monsoon. Another 8 months we need to survive. You need some technical solutions which are viable at a local scale and at different parts of the country, because as Professor Sarma was highlighting to you, because of the distribution of the rainfall is not uniform across the country. So these are the 3, and risk due to operation, products and services are also add to that, okay? And then risk due to basin condition also will add to that. So water scarcity, if you look at it, is it really unavailability? I mean, that is the big question. I do not agree with many of the documents. We do have a water scarcity. But if you look at the definition here, water stress, yes, I agree with you. I completely agree with you. We have a water stress, because otherwise we would not be seeing our village. In every village, you know, particularly women folk carry water on their head even today, okay, for kilometers. So we have water stress. That means that is because of quality and accessibility issue. If I don't know whether you can see this bar on the left side of the governance chart. Okay, this is blue, in blue color. It's not very clearly visible here, but you can make out. This is water stress. But water scarcity is only an availability. So my ladies and gentlemen, many urban areas, we might have faced water scarcity, but as a country as a whole, we do not have scarcity. I will demonstrate that through examples. So water risk for businesses are physical, reputational, and regulatory. Status of water resources in the context of climate change. So we all agree that there is scientific evidence, except the present president of America, Trump. Everybody agrees scientific evidence is very clear for the climate change. Climate is changing, will continue to change. And many of the impacts of climate change are affecting society and the environment through changes in global, regional, and local water systems. Climate change will affect global water resources in multiple ways with complex spatio-temporal patterns. That's what Professor Sarma was talking about. Feedback effects and interaction between physical and human processes. This includes directly through hydrological systems in terms of water availability, water quality, and extreme events, and indirectly through changes in water demand that in turn can have impacts on energy and food security. This is the report I was referring to, World Water Development Report, WWDR 2020. So the status of water resources in the context of climate change is expected to make droughts more intense and increase global flood risk. You are seeing that. Some areas are always under flood and some part of the year, and some other areas are having a lot of drought. So the climate change, water, and sustainable developments go hand in hand if you want to really look at mission water as a solution. So climate change scenario trends in water availability. This is again a picture from WWDR report. So you can see very clearly India, the blue water, there is no problem. You see, it's all blue. Okay. So trends in water availability, that is relative change in the annual discharge at 2 degrees centigrade temperature increase compared with the present day. That means if the temperature goes by 2 degrees, so decreases have already been observed, and river places such as West Africa, Australia, Yellow River, China, and the US Pacific, but thanks, India doesn't appear here. Okay, so this is also another change. So even though the extreme events are also available in India, what we do not have the scarcity issue, because I'll show you later on with numbers that we do not have water scarcity, but definitely we have water stress. So this is the story I would like to show you. the world average annual precipitation, if you look at both India and China, is more than 1300 to almost 1500, more than 1000 to 14 to 20. The green is almost 1000 millimeter to about 5000 millimeter. Okay, 1000 millimeter average annual precipitation is rainfall. 1000 millimeter to 5000 millimeter. Look at that. That is a very good number, and we are seeing that consistently because our IMD manages an excellent data on the rainfall. Okay, so definitely there is a decline in urban water availability. I told you some cities are running out of water. Bangalore running out of water, Chennai running out of water. That is because of other issues, as I told you, water stress, not water scarcity. That is due to the high population density and utilization pattern. But if you look at the projected water scarcity in 2025 by IWMI, okay, International Water Management Institute, very interesting to note that India is put, the entire country is put into physical water security. So this is the number I am having problems with. This is the number I'm having problems with. I do not have problem with economic, you're putting under economic water security like what has been shown for China. So even our coastal areas have been shown as a economical water security, but scarcity. But India also, if you, I think, analyze properly our data, maybe leaving out some parts of Rajasthan, but that also, if you've traveled extensively in Rajasthan, things have changed. Rajasthan has really transformed. Some of the transformation projects have been taken place in Rajasthan, whether it is restoration of river Saraswati basin, or many attempts have been going on. I would like you to please look at some of those very fantastic work which is being done in Rajasthan on water restoration. So severe physical water scarcity for at least 1 month per year, I can say. Okay, 1 month per year, but not more than that. So water quality and demand. Let us look at the water quality issue. The world freshwater resources are increasingly polluted with organic waste, pathogens, fertilizers, pesticides, heavy metals, and emerging pollutants. Water pollution by organic matter is growing. And I think this is all with livestock farming and everything, freshwater. Coastal wetlands are also adversely affected because of human effects or human impact, because a lot of population moved to the coastal areas. So looking at the demand also, let us see, globally with increasing population and development, with increase in development also, water withdrawals are also continuous rise. Because there were many industries coming, they'll draw a lot of water. Water demand is projected to increase by 55% globally between 2000 to 2050. That means almost 1.5 times, we have to, we require extra water. The increase in demand will come mainly from manufacturing, electricity, and domestic use. Scale of investment ought to increase significantly water infrastructure. So to really solve some of the emission water problems, we need to put a lot of money into water infrastructure. So today's topic is on hydro diplomacy. Okay, and I mean it is going on from last 7 lectures you might have seen. So if you, this is a very interesting book I found by Ganesh Pangre, okay, and related to water, water ethics, hydro philosophy, hydro carelessness, hydro intelligence. So you look at it, hydro diplomacy. Hydro diplomacy almost put at the bottom. So, so why I say that, when there is enough water, there is no diplomacy required. Okay, if there is enough water. When there is a shortage of water, then you start fighting. So managing transboundary waters is not the domain of water managers, but involved with other consideration of foreign policy, diplomacy, trade, and related issues. You see now, that's also I'm trying to tell you. That means it is not really the water issue. There is no knowledge of water is required if you want to solve the transboundary water issues, because they are all completely controlled by something else. That is foreign policy. How are you, our relationship with our neighbors, our diplomacy, trade. So it is also linked to trade. So if somebody doesn't listen to you, then you say, I will play with water. So coordinated from local to national to transboundary levels. Hydro diplomacy enables countries to negotiate agreements on water management. But I'm telling you, I'm very, very sorry to say this is a definition of this, but we are unable to have a diplomacy between the states. How can we expect to have a diplomacy between the neighboring countries? Very, very challenging actually, because it is controlled none other than the topic of water. That is foreign policy, trade, and other ratios. For transboundary agreements, so for water to work more effectively in the ground, they need the involvement of water users at multiple levels of governance. So if you really look at, to solve this problem, it cannot be solved by just the administrator. There must be a clear understanding. Law is fundamental to just and effective governance of natural resources for the benefit of the people and the nature. So let us look at the challenges faced by the India's river basins. So water is a state subject. Why I'm bringing this diplomacy is water is a state subject, center only to manage in case of interstate disputes. Great challenge to adopt interlinking of rivers, and environmental damage is also another reason. And you can see how many disputes are there in India. Every state is having a dispute, and major disputes are listed there, whether it is Godavari or Krishna or Narmada. All of them are plagued with a lot of water sharing issues. That too, very small quantity of water. That is what I do not understand, why we haven't looked as a country try to solve these disputes. So let me take you to the water resources. India's water resources, from the annual water resources through precipitation, is 4,000 billion cubic meter of water. That is a lot of water. Surface water resources is about 690 billion cubic meter of water. Total utilizable groundwater is about 400 billion cubic meter of water. Unutilizable, see, from the unaccounted 2,000 billion cubic meter of water, close to 2,000, okay, almost 50%. Little can be done to check evaporation. So we can't do much on the evaporation because we have built large reservoirs and lakes, man-made lakes. So evaporation, and also ours is a temporal, country with a large, most of the period, very high temperature across the country. So evaporation is very high. And deep percolation also, the flood water to oceans, that is the one which I'm talking about, ladies and gentlemen. You need to focus today on the flood water which is joining the ocean. Okay, and also what is called as non-crop evapotranspirations can be seen as variables. So that is also a lot of work is going on. My colleagues in University of Science have done a lot of work on, Professor Muddu Shekhar and others have done on non-crop and non-crop evapotranspiration models to understand how that can be used as a variation to conserve water. So the story of India, for the people who are outside the water resources, 400 rivers in total. You can keep on counting, that large 25 basins, but major river basins are 7, which most of them discharge to Bay of Bengal. Okay, most of them go to Bay of Bengal. Total surface runoff is 77%. Indo-Gangetic is the third. This is the river which dumps through Padma River in Bangladesh, is the third largest discharge in the world. That means you can see a lot of water simply joins the ocean. East and west flowing rivers in the Western Ghats area, most of the rivers in southern India, in peninsular India, actually originates in the Western Ghats. Eastern Ghats also, there are some rivers, but they are smaller. But Western Ghats has large rivers like Godavari, Krishna, Tungabhadra, okay, Kaveri, all of them are very rich in water. So they're both, the west flowing rivers are smaller length, but they are the very cleanest and large quantity of water, because large rainfall happens in the entire, starting from Maharashtra to Goa, Karnataka, Kerala. Okay, this is the Western Ghats. And the Himalayan Peninsula drainage system, we have 2 drainage systems. That means one is the entire peninsular drainage, which is either to Arabian Sea or Bay of Bengal. As I told you, Bay of Bengal is the maximum. And then the other one is basically the Himalayan, so which is also joins the Bay of Bengal. Okay, so the Himalayan rivers, only one river will join the Arabian Sea, which is the river Indus, which goes, actually bonds in India, goes through Kashmir, and then comes back through Pakistan and pours out near the Gulf of Kutch. Okay, so that's river Indus, which is a civilization, gave a civilization to the whole world. So government is also thought about this, that we need to aggregate everybody together and look at the data. See, water resources data have to be very critically. We still do not have proper database. That's why we are calling ourselves into a problem, and other countries take our data, whatever we put it up, and say India is shortage of water. This is the real problem. So we need to invest a lot on data, lot on quality data. So Jal Shakti Ministry, Water Power Ministry, has realized that and formed a new Jal Shakti Ministry, and it is also taken up river development and Ganga rejuvenation and many other. Brahmaputra is also one of the other very important thing. River linking, I don't want to say too much. I've already touched upon a little bit in one slide. So I'll tell you that's a major problem, which I think we should not have attempted, because we are changing the terrain completely by doing that. So if you look at the annual rainfall, as I told you, I've looked at from 1901 to 2000, almost 20. I will tell you, nowhere we have gone below 1000 millimeter rainfall. This is the actual data taken from IMD. Okay, I myself have taken the data. Nowhere except maybe 1 or 2 years it has gone to 980, 970 millimeter, but nowhere annual rainfall has gone down less than. So when you have 1000 millimeter rainfall, we cannot call ourselves as a water scarcity country. So runoff, let's look at it. Why we need to look at the flood water? Huge runoff, Indo-Gangetic Basin, and most of the west flowing rivers, Godavari, Krishna, Mahanadi, Narmada, the west flowing rivers are actually very small, which are flows from the Western Ghats towards Arabian Sea, and huge dams. Average discharge is huge. See, as I told you, west flowing will not utilize much because there is not much of industries as well. Western Ghats, except city of Mumbai, most of the other cities are very small. Again, Kerala, it will be, you will see a little bit bigger cities. Otherwise, in Karnataka and Goa, coastal cities are population-wise very small ones. Flow rates are much higher and much cleaner because of it has come through very high velocity terrain, because the gradient is very high. So what is real problem in India and many places is we have reduced the water potential and its relation to changing processes, because we have urban habitat. Many of the urban areas had a lot of soil erosion and siltation. Water bodies lose their capacity to store water. So earlier, when nature used to recharge the surface and groundwater on its own, because we used to have a lot of green cover. Slowly, thanks to India's efforts, green cover is coming back. It is increasing. It is increasing, but it needs to increase much more. But unfortunately, our population is also growing up. So degradation of forest is one thing we need to seriously consider as a solution for water. See, we should actually stop degrading the forest. We need to actually increase the forest percentage in entire Indian land. So increase soil erosion. See, that is also because of degradation of forest. So if you have a lot of vegetation, then soil erosion also will come down. Have reduced the resident time of water. So that means, see, as soon as the two climate change has changed so much, earlier it is to happen for several days of rain. Now all will happen in 4 to 5 hours. So the resident time of water is also very small in the ground. So whatever falls on the ground due to climate change, very high rainfall, will not have a chance to get in to the ground. It simply joins the streams and goes into the ocean. Okay, so actually it should go through the different layers of the earth that we have actually spoiled. With increase in population, water demand is also increased. As I highlighted earlier, demand is also gone up. That is why we are seeing water stress. So let us take a look at the stages of the river, how the Indian rivers are, whether it is Himalayan rivers or Western Ghats rivers, almost most of these. So they're born in the hills. Say in Himalayan, they're fed by the glaciers or snow, but in most of the other places, fed by the rainfall, and all of them will flow through very steep gradients initially when they come to the plains. And that's where they have the confluence of the junction, okay, where the two rivers join, and then meander and other things will happen. And then once it goes to the coastal area, it becomes calmer. That means the sections becomes wider. See, flows with low velocity, lateral erosion dominates, wide channels, extensive floodplains, braided channels, levees and oxbow, meanders, deltas. But however, in the middle course is flows with moderate velocity, vertical and lateral erosion is plenty of streams will be joining. But however, in the upper course, very high velocities, V-shaped valleys. So except leaving some major important dams, so we have avoided actually the upper course of building dams. Most of them are written in the middle course. I'll show you that later also. So the conventional rainwater harvesting techniques are actually very good for actually our terrain, like underground dams and coastal reservoirs. I'm going to talk about that. Those are all actually both of them. Please understand, you can go back to the World Water, the WWDR document of 2020, which UN Water has brought out. These are the two new topics have been covered there, and we are referred quite extensively. My work has been referred 2-3 places in the UN Water report, which was astonishing to me because I'm not a water resource person. So let me take you through India's intelligence in storing water. Okay, India had a very rich knowledge. So they knew, most of the Indian part, they knew that 4 months or 5 months annual rainfall will come. So they need to store water. So India's traditional water harvesting structures mostly vanished now. So only in some districts or some, they've been reviving. So maybe some of you may not have even heard, there were ahar pines, bavdis, okay, and Kodin in different parts, it is called different names, and they were very, very popular actually. India's traditional water harvesting structures, you can see recently, I think Sharad Jain has read an article in Hydrological Sciences. It's a very interesting paper, you have to look at it. But I was keep talking about this for a long time, but I saw that paper which was found very interesting because India had a very rich knowledge that they knew that they have to store water. Basically check dams, weirs, charus, and all different names they call in different parts of the country. And this is Bengal's inundation canals. These are very unique. Even, the Britishers are appreciated this concept of inundation canals because after a few months of the rains, they cut the bunds. So then they will use it for growing one crop. Okay. Kuni Bandara is a network of well-like structures interconnected through underground tunnels. So large number of them, you see that in the Western Ghats, in the hills, okay, large of them. But you might thought that there is a natural cave. No, it's all man-made for storing water. But unfortunately, the people that knowledge has gone. So they don't know what for it is, and they're not utilized. But again, they were being revived now by many. So as I told you, Surangam, they are called Surangam, Kerala 8th century. If you go to Udaipur city, it's a beautiful network of all lakes connected. Pichola, Fateh Sagar, all of them are connected. See, very, very, very nice to see the Udaipur canal linkages. And you can see, I have not seen dried up, only once in a while, you will see that beautiful Udaipur Palace lake, the hotel, which has been now converted to hotel. You can see that there very nicely. So there are many such structures, many we need to actually learn from our history, many of them. There are a large number of rainwater harvesting structures. Government of India, thanks to Government of India, many urban areas have taken up large number of very roof harvesting structures, but that's not the only one. See, I told you check dams, nalla bands, contour trenches, percolation tanks, soak pits, subsurface dikes, sand dams, infiltration wells, injection wells, water pools, and then subsurface dikes and dams. They're a little different, underground dams and coastal reservoirs. So you can see for the entire catchment of the river, okay, entire the basin of the river, you can do these things depending on the area. The solutions today are becoming much more easier because of the innovations in geotechnical engineering, where you can use the geosynthetics materials. New materials have come which make the same work much easier, to whether to drill or to retain or to filter, all that is becomes very easy because of the new geosynthetic materials have been introduced, and their life also is little longer when compared to conventional concrete type of material. So rainwater harvesting structures, I'll just show you some of the pictures. This is the contour bunds, pits and shafts. So you can, whatever falls on the hill, you can actually channelize. Even here we can do it. In our campus, we can do this beautifully. Then take it through and put it to the permeable materials. So these are called simple boulder checks. It can be done locally. okay, using Pradhan Mantri Grama Yojana. These are all been done, which reduce the speed of water, prevent soil erosion, promote soil moisture, and then in turn supports the natural vegetation. So these are recharge wells, again done so that you infiltrate the water to the greater depth. Then recharge bore wells that will go to the much deeper level, so it will reach the aquifers now. So constructed water flow is more. See, if water flow is more, we are going to use the recharge bore wells, and enables rising of water level in bore and deep wells, rises water table in downstream areas as well. Okay, these are water pools. So these also, see, there is a knowledge here. See, what is, if it is a shallow water, it will dry every season. If it is a deep, here is at least 10 to 15 feet, then your water evaporation loss will be restricted to the top 1 meter. So the at least 2.5 meters of water will remain for the entire season for another 6 to 7 months of summer. So water storage in a column with minimum spread area is the key aspect of the technology. So it reduces the evaporation, source of water for human, cattle, birds. This is the fantastic things have been done in many parts of southern India, I have seen, and many agencies have come forward to do that. And here I have put a sort of living work of 2016. So these are what I call the nature-based solutions. Nature-based solution refers to sustainable management and use of nature for tackling the socio-environmental challenges. Water can help fighting climate change. So solution of these, you can actually fight the climate change. So you cannot simply blaming on climate change, oh, nothing can be done, and every year it is a flooding. No, you have to change through the water itself. So water can fight the climate change. This is the beautiful concept. These are sustainable, these are affordable, and there's, please note that people have shown they are scalable. Okay, when forests upstream are kept intact, water and soil runoff will be regulated by trees. Soil runoff will be regulated by trees, which in turn safeguards the reservoirs. So one of the other mission was river rejuvenation works. Many of the agencies have taken up river rejuvenation. Please don't rule out them. They are very unique projects which can be done, which should be done. You may not see the result in one season, but if you persistently at it 3-4 years down the road, your rivers will start flowing. Action to protect, sustainably manage and restore natural or modified ecosystems that address the societal challenges effectively and adaptively, and simultaneously providing human well-being and biodiversity benefits. You can improve the SDG goals by or attack the SDG goals through the water can fight the climate change. So I have just put a picture from the document. This is a natural infrastructure for water management. So all kinds of there. See, in urban areas and very remote areas, villages and forests, what can be done? Okay, there are plenty of technologies here. There are plenty of solutions, starting from water harvesting to wastewater recycling in a city, urban area, to many technologies can be adopted, protecting and restoring mangroves in the coastal areas, protecting and reinforcing with freshwater ecosystems, all, this kind of nature-based solutions with technologies, geotechnologies in newer materials, utilizing newer materials, we can solve the problem of water, and this water will fight the climate change. So the afforestation is one key aspect of this, which prevents the soil erosion, accelerates water infiltration, attracts water molecule to the gravity zone, enhances water retention through capillary action. Long-term permanent solution of water problem is only. So please plant a tree every day, if possible. So we have also taken up a step. I always encourage in IIT Guwahati, even though it is a lush green campus, I keep asking our horticulture department to plant more and more trees, because all of them will not be surviving. Some of them will survive, which is very good actually, So this is another topic which I wanted to tell you, the underground dams, I just told you, which has come in the WWDR 2020 document. So this is surface, this is a surface dam. This is what we have built throughout. Build a dam, so large gravity forces, it will come, and then it has to be a very strong one. But if you go with a subsurface dike, see, here is the ocean, and ocean water, that is the salt water, will be stopped here, and the fresh water will be stored backside. So through this, recharge will happen. So underground dam intercepts the groundwater. It can be built anywhere. It can be built in coastal area, it can be built in the hilly area, it can be built in the towns, villages, and river courses and streams, anywhere. Very simple technique. I'll show you the next slide how simple it is. Japan has adopted this extensively. One beautiful thing. So if there is an earthquake, this dam can collapse, and then all the downstream water can be, remove several villages, towns which are downstream, and a lot of displacement of people will happen because of dam breakage. But here there is no question of consequence of dam break. There could be some leakage. It's all right below the ground, but otherwise there is no consequence of damage. So this is the underground dam is a very safe, but definitely it stores below the ground. So it is only, you can take 30% of the volume. It has to be larger than what this kind of over surface ground. And there is no fear of evaporation. See, evaporation losses are too high in the surface dam, but in the underground dam, evaporation losses are nil actually. So it need not be only in the river course. See, in Japan, they have done almost kilometers other side of the river, on the either side of the river, the surface dikes. These are called subsurface dike like this, and you can store water here so that the seawater will not penetrate into the interior, and this will be available, and it will be below the ground. It's always available to you. So you can see so many large dams are constructed, large dams underground in Japan, because which is an earthquake prone country. It's in the ring of fire. Large number of earthquakes happen, but have you heard about any dam breakage there? Because they're all below. So you will never hear about dam breakage. The construction of an underground dam is so simple. I'm going to show you a simple one. You take a geomembrane, what I've shown in the right side of the picture, and make a trench. This can be done in 2 days. Depending on the geology, you have to do that. And then you have an infiltration well as well in the back side of this, where the flow will be in this direction, for example. You can put this geomembrane and close it. Then automatically, that's all. That's the underground dam. In some smaller ones. In other cases, you can use multiple materials. Concrete can be used. It could be used with many new materials can be placed here. With bentonite can be used. You really creating a cutoff wall. So this is the kind of subsurface dam below the ground level. You see, they have constructed and then close it. See. It can be done with concrete, it can be done in brick, it can be done in boulders, anything in the river. Over a period of time, water may not be visible on the ground, but it will be below. So it is available to you. When it is not visible, you cannot even contaminate that also. So another area is the water uses. For example, if you look at it, any country, agriculture use is the maximum. So we need to also bring in revolutionary practices in agriculture. This is for a country like India, which is agriculture-based country, we need to do something revolutionary, competing water users, so that see, whatever we are talking about, close the tap while brushing your teeth, can only save very small quantity, because we are using only 8% of the total water for the domestic use. But if you look at the agriculture use, if the same tap closing is done for the agriculture use, even the small is equivalent to the entire utilization of domestic use. So that's the kind of numbers you are talking of, whether it is the developed world or it is the developing world, both are similar. You see, agriculture is used even in America 70%. Agriculture used in India is 82%. So develop revolutionary scientific usage of water is one other area. So anyway, I have shown you some of these things. I will rush through quickly because, so as I told you, another idea is the coastal reservoirs, the developed floodwaters. So I'm not going to show you because some of these I've talked in the first lecture. As I told you, if some of them are new, India has built close to 6,000 large dams. This is the only country, the third largest dams construction is done in the world is after America and China, India. Okay, but how much of water we are storing? 10% of the average annual rainfall, actually less than 10%, 8%. 8% of the average annual rainfall. That means 8% of the 4,000 billion cubic meter of water we are only storing. So even if you want to store, people will say, oh, if you take away all the water, what will happen to the oceans? I am telling you, even if you want to do, you can only increase by another 4%. So nothing changes. You are going to drastically, you can make changes. So still large amount of water will go to the ocean. So what I'm talking about is you're going to take about 3 to 4% of water, which is joining the ocean, and store it and use it in the non-summer, non-winter rainfall seasons. That is what we are talking about. So this also I've told you, as I told you very clearly, no shortage of water. Okay, there is only a shortage of storage. That's what we have to solve the problem. Once you solve the storage with using sustainable solutions, I think we can do it. And small is beautiful. Small is beautiful. You don't need to build very large dams. Unfortunately, out of 437 large dams which are under construction, whole world has stopped large dam construction, ladies and gentlemen. But India, still we are building 300 large dams. Where are they building? In Northeast. That's where is a worrisome, because it's a very earthquake prone country. So anyway, that's what I've talked about. And also I will not tell you much about the concrete. Concrete is not a material which is infinite like earth. Earth is a material which will be there forever. Okay, earth is an element which we all feel that we preciously do puja to it. It's like a 5 elements. But the concrete is not a material. Concrete survives only maybe 50 to 70 years. After that, it goes away. So at that time, what that means, all the dams which are constructed using concrete, we have to remove. We have done some calculation with my friends in Australia. By 2150, most of the dams have to be removed. Most of the concrete dams have to be removed, because concrete becomes a fragile material after about 70 years. So looking at even if you use the dam rehabilitation projects, most of these dams will. So will you be able to construct the same dam at the same location? I'm not sure, because environmentalists will not allow you. So the country, when we got independent, we started with an idea of the temples of modern India. That was in 1962, were dams. Maybe at that time it was correct decision, but today this is not the decision. So where is going to be the next temple? Because we are built everywhere, and we are only now constructing in the Northeast. So the future solution will be coastal. I will not take much time, because I've already talked about it. This is our book. Some of you are interested. Sustainable water resource development using coastal reservoirs. Okay, and the advantages, disadvantages, I already talked to you in the first lecture, so I will skip through. And this is the second generation coastal reservoir, which is really fascinating to see, which is implemented in China, in Shanghai. I'll just show you the Shanghai's experience. This is what it is. In 2008, Chinkosa coastal reservoir started its construction. 2010, coastal reservoir starts to pump fresh water from without desalination. So look at this, 2 years. Okay, but how much time we took Sardar Sarovar? As 55 years or 58 years actually. 2017 we inaugurated, and it was foundation stone was put in. Why? Because a lot of displacement of people and a lot of transdisciplinary, this hydrodiplomacy was never happened between Maharashtra, Madhya Pradesh, Gujarat, and many states which dependent on the river Narmada. Okay, so some of the beautiful coastal reservoirs. This is in Netherlands. See, so much of new land is created in Netherlands. Okay, this is the dike which has been constructed across the Wadden Sea, and this is completely Iselmar lake is completely a freshwater lake, and you should go and see that. It's so beautiful. This is the road on the dike. This is one straight road. 30. So in 1932 it was constructed. They took 5 years to construct this one. So almost 35 or 36 kilometers long in 1933. Okay, so 25th September, Netherlands was officially opened, but this was done for the flood control. Otherwise, this area was always getting flooded. So large freshwater in Hong Kong, Highland Reservoir, Shipuk, Power Claw. This is the Power Claw. After all this, Hong Kong had never had any shortage of water. Otherwise, you used to see this picture on the right side. This was Hong Kong carrying in boxes, water rationing. So Marina Reservoir is one of the classical example in Singapore, but Singapore can do it because they have a strict control on the quality and this thing. So this is a barrage is also very interesting for civil engineers, because this is a concrete dike which will rotate actually. See, this crust gate will be vertical when seawater and fresh water in Marina, and it lowers when there is heavy rainfall. When it is rainfall is higher, and the high tide is also there, then it will be there only. Then the pumps will start pumping out the water. So there are it's a fantastic steel crust gates, almost 26.8 meter long, are there for a stretch of 350 meters. This is the entire Singapore, and Marina Barrage is located here. Okay, so you can see So if they completely close it, this is what we call first generation, then entire pollution and usage water all will come there. So that is what the problem is with the first generation, but the second generation coastal reservoirs are much better. This is a beautiful Marina Barrage in Singapore. It was before 2005, and look at that now, how it is. Okay. So the deep fishing harbor, which was inside earlier, now the harbor has been shifted outside. Okay. So all these can be possible in a country like Singapore, but in India, you have to fight with the fishermen. So Shimangam Sea Wall is another beautiful, in Korea, but it is a failed one. I'll tell you, because the first level, this is a 400 square kilometer. You can see that. This is the dam. Beautiful. It's beautiful. One side sea, one side fresh water. Okay. This is the sluice gates which are controlling. So these are constructed using what is called a geotextile. I just wanted to tell you geotechnical how much. As a concrete surface is very, very thin. Okay. It's entirely with geotextile using the same soil or the same sandy silt in the bottom of the ocean to construct this technology. And very simple with geobags. Okay. Cross section of the sea dikes, they just stack together and then create the sea dike. This is how it is done. The geotextile is put and then pumped into this, water will go out, sand will get into the bag, and that will create a bag. So you stack up that, and the dike construction will happen. So there are a lot of advantages. This is the book I was talking to you, Water and Climate Change, WWDR 2020, where our work has been referred. There are so many advantages of coastal reservoir. I will not go through because I've covered this in the beginning. So one beautiful project I would like to highlight to you is Kalpasar project in Gujarat. This is the dream of Honorable Prime Minister when he was the Chief Minister of Gujarat. So a lot of investigation has happened. If you wanted to see a coastal reservoir, large one of the largest in the world, which will happen soon maybe, because now geotechnical investigations are going on, you can go to a website called Kalpasar project. Every detail is there, all the geotechnical report, water studies, major 5 river basins will actually culminate there. And the beautiful idea is, once that dam is constructed here, they have a contour canals entire of Kutch. So automatically this entire area will become green and agricultural thing. Kalpasar dam will connect actually the Bharuch, Bhavnagar and the mainland, and which reduce, otherwise they have to go all the way like this. Now there will be a beautiful highway on this. See, that's a Kalpasar 64-kilometer long dam which has been planned. So my idea is, we can create such coastal reservoirs at major river mouths or wherever you have a very high this thing, connect them with subsea pipeline. When what happens here is you are at a zero mean sea level. So there is enough, you don't need to cut anything. So you can just put a pipeline through this connecting. Then there is a beautiful way of connecting Ganga to anything, not only Kaveri. See, Kaveri is right here. Krishna is right here. Godavari is right here. Okay. Mahanadi is right here. So you don't need to just connect Krishna to Kaveri. You can even connect to Gujarat based on this, because this is a fantastic idea which can be implementable. It is also because it's not very great difficulty. We have 8,000 kilometers. This we have also patented this concept. So India is not running out of water, but water is running out of India. This is actually true. Desalination is very expensive. There is no point in putting the same water, fresh water, what we get into the ocean and take back that water and clean it, and environmentally also damage the area. And it is very expensive also, energy intensive techniques, desalination. So I think desalination is not for our country. Underground dams is a fantastic concept which will augment the groundwater resources as well. And we have to start looking at that in a small scale to big scale to large scale, like what Japanese have done. Cost of coastal reservoirs versus alternate water diversion schemes is much, much lower actually. If you look at the financial, we have done one case study in Mangalore and shown them that it is very viable and is doable. And they don't need to be worried about the damaging the environment, because we are going to create actually new wetlands through this. So, and also you can choose where you want to put your this thing, where complete erosion is there, we can do. Engagement with community, government agencies, stakeholders, that is what is about diplomacy. That has to happen more and more aspect of the significant local water issues. So we need to have a diplomacy at a local water level, local water issues level, educate the masses, and scientific utilization of the water to the farmers is a very key aspect of solving water issues and water problems. So I would like to also invite you to become members of the International Association of Coastal Reservoir. So go see the website. And then also we are conducting the first international conferences on sustainable water management and coastal reservoir in Nanjing, China, for which I'm the chairman of the conference. And you can see the website. If you go to this website, we can see this also. This will be next October 2021, 18 to 21st October at Nanjing, China, at Wuhan University, very close to the Shanghai coastal reservoir, Chinkosa Reservoir. So we are also arranging a trip to Chinkosa Reservoir through this, because otherwise, if you go alone to China, you cannot see Chinkosa. Chinkosa is being protected by the military of the Chinese army. So through this, if you go, they will actually make an arrangement to visit that. It's a beautiful project. Thank you very much. Thank you. So over to you, Anamika.
Yeah, thank you so much. Thank you so much for this insightful presentation. And I can see already a lot of questions are coming in. Even I am feeling like asking a few questions. But before we do that and open it up for questions, can I request our discussant, Professor Arup Sharma, to share his views, and then we will open it up for question and answer.
Thank you, Anamika. It was a thorough discussion, rather thorough presentation on various aspects covering all the issues, most of the issues of the water management scenario. So I don't have much to add, but then one point just I am highlighting here that Professor Sitharam has already told that if we can just take 2% of the water, seawater, from the fresh water, then sea is getting less by 2% only. And this is important because I highlighted one point that 97.4% of water is in the sea and only 2.6% is the fresh water. Now, so if we take from 97.4, if we just conserve all those water in the land, only 2.6%, around say 2.5%, then increase in fresh water become double. That is, it increased by 100%. So that's the important fact. So it will not damage the sea, but then conservation is very important, and talking on various way of conserving that Professor Sitharam has explained a lot of things. We are also advocating one term that we call the ecological management practice. That is, say, ecologically balanced. This approach is that ecologically sustainable approach, so that we can store our water and sediment. We can control sediment also and can have water for our need. So that's the approach we are talking about, and this approach has been implemented. I'm happy to say that this approach has been implemented in our India as well as abroad also. So this is a quite good thing, and that way we can proceed by different innovative way to solve the water problem. To conclude, in fact, Professor Sitharam has also in India. From this part of India, from the northeastern part of India, there we're saying like Dakor Boson that we call that Pukuri Khania Rakhiba Pani Tebeke Dharma Koriba Jani. That is, there is more virtue in digging a pond than making a temple. Brikharupanot Odhik Dharma Mot Mandapar Gurutar Karma. There is more virtue in plantation than making a temple. So that kind of sayings were prevailing in the northeastern part of India long back. And today, I feel that we should train our children in rhymes form that we should conserve water. Say we can change the rhymes from twinkle, twinkle, little star to raindrop, raindrop, fill our glass. Don't go to ocean, stay with us. So thank you very much. With this very brief note, I'd like to close now because there are a lot of questions. Time is running out, so we need to be conservative in time. Also, thank you very much. Thank you all. Yeah, Anamika.
Thank you. Thank you so much, Professor Sharma. Let me just quickly go back to the larger discussion that we had and the insight that Professor Sitharam also brought in. Before we open it up, I have a very quick quick question to actually, sir, to you, and that is because I work so much on the Brahmaputra Basin, I have been discussing with Bangladesh too on several aspects related to India, Bangladesh relationship related to water. The concept of the coastal reservoir that you have shared, what kind of diplomacy would be required with the neighboring countries? Will there be a role that they also have to play in bringing this up?
Yeah, I think it's a good question. Brahmaputra actually dumps large amount of flood water into the ocean. You know that. So most of the time, in the monsoon time, half of Bangladesh is full of flood. Okay, and I think in the Bay of Bengal, if you are able to create very similar to what Chinese have done, it solves the problem of Bangladesh more than India. Let me tell you, it is for Bangladesh. Once the problem is solved for Bangladesh, they will not curb problem, because upstream water, you are on the upstream side. Assam and all the northeastern states, Arunachal are on the upstream side. So you are the water actually goes through you first. Than the downstream. So there is always a controversial between, so the diplomacy is you should convince, maybe this is the good time to convince the Bangladeshis so that you should have a coastal reservoir in the Bay of Bengal, which will also give water to West Bengal, Tripura, that's a point I'm talking about. That's the place. So we should convince them. Half the problem will be solved, let me tell you, ladies and gentlemen, if you are able to solve the problem of Bangladesh water. So this is all because, when they don't get water, they will actually create a lot of issues and challenges, problem. They will cut off. See, this is what the diplomacy is about. See, when you don't give them a fresh water, enough fresh water, what they say is, okay, we will cut the canal. You cannot use it for transportation. See, that's what they're doing. They'll stop any goods movement because unfortunately, entire Northeast is landlocked unless you have to go through Bangladesh. If you want to use the river, as a mechanism to transfer your goods, you have to go through Bangladesh. So to do that, you have to have a friendly friendly relationships. And if you help them to solve this problem jointly with the World Bank or anything, and then, automatically they will also slowly open up because it becomes a society which is very friendly once they solve a problem. Otherwise, you go to Bangladesh, I have been there. Let me tell you, they have water everywhere. There is not even a drop of water to drink in the monsoon, particularly in the monsoon. You see, it's large amount of rainfall. You yourselves have seen Assam, Guwahati receives almost 3,500 millimeter annual rainfall. Okay, and Bangladesh is also on the similar numbers, 3,000, 4,000 millimeter annual rainfall. Okay, and they're plagued with lot of issues of other like thunderstorms and all that. One coastal reservoir will be a boon to Bangladesh and also to India. I think we need to look at that because large amount of water, there is no shortage of water. If you share, you can't even store even 1% of what Brahmaputra and Ganges dumps into water or into the ocean. You cannot even store 1%. That is 1% is actually 3 times or 4 times what is the entire region requires. Okay, that's the kind of scale you are going to talk about. Instead, you are trying to build the dams in the uphills. There is no water, ladies and gentlemen. And also, you are creating a dam which may be vulnerable to earthquakes because this area is very highly prone to earthquakes. So if there is a big earthquake, God forbid, in the last 100 years has not happened, but if it happens, I'll tell you that today the population density is also high, not like in 1950. Okay, so that's what you have to look at. Thank you.
Yeah. So there is a question which is quite linked to what we are discussing. One is that the suggestion about having an underground dam, will it disturb the ecology at all? And if a kind of scientific study already exists which shows that there will be no such impact. And the other question, again interlinking to this, is that do you think that if it is important for also the institutions to have interlink, like traditional, local, state, center, all of these institutions should work together if we really want to kill this myth of water scarcity that exists. So these are the 2 questions that probably you can respond.
Coming to underground dams, let me tell you, it can be done in different scales. Small, very small, across a stream. You don't need to go against Brahmaputra. Maybe Brahmaputra may be a very difficult river to tame. So you will not have a time to really put an underground dam below Brahmaputra river because it's always flowing with water. Okay, you might have to look at some of those Dibang or Dishang, little upper hills, or Kapila, such rivers only we have to look at it. Maybe some rivers in Meghalaya. Okay. Coming to ecology, I don't think you're damaging ecology. You're going to actually augment ecology. You are going to, enough water would be available to you, your trees will grow much better, and newer, green cover will grow, because on the ground, you are not storing any water. It will be same trees. Trees will grow much faster now because availability of water is plenty. So there are one or two issues, that is salt collection. Because once you stop water for a long period of time, there will be a salt accumulation. But I think, some agriculturists have to look at it. And there are mechanisms to reduce that, because you have to choose some of the species which actually suck the salt. So the trees which you are going to select, they will actually utilize this salt. Because whenever water is stopped for a long time, salt will gets accumulated. So we haven't understood much of those things. I think there are some good literature available, because I'm not in that chemical part of the study. So you have to look at with some of those chemistry people or biology people to look at some of those issues. But the solutions are available. They're not big. As I told you, very similar country like Brazil has more than 500 underground dams. Brazil is also in the equator, please understand, has large number of underground dams other than Japan. Japan has more than 150 such dams. Japan is constructed with a different purpose. The Brazil is constructed with a different purpose, both for water. But in Brazil, they have a large rainfall, just like monsoon here, 4 or 5 months, huge water, but later there is a dry season. To store water there, they're doing it. In Japan, maybe because of earthquakes, they don't want to build anything above. They want going underground. Thank you.
So the other question is about how can we integrate science into the traditional water storage or water harvesting systems? How can we bring them back? Is there a technological answers to this?
Yeah. I think, there is a greater, anything in civil engineering, it has changed is in geotechnical engineering. My friends may agree with that. Why? Because, see, we haven't invented any new material in the last 100 years after concrete has come. Okay. New material invention has not happened in civil engineering, only slight improvement, some how to set the cement much quicker, and concrete, how to prepare high strength concrete. That's what we have done, but we are really not invented a new material. But geosynthetics is a new material. You should see great of innovation using geosynthetic filters, geosynthetic membranes, geofabric, that is two-dimensional, reinforcement. It can do multiple jobs. Okay, the beauty of geosynthetics is it can work as like a filter, like a cloth. It can also as a membrane. It can stop completely. It can give tensile strength to the soil. So, as you know that we have the oldest dam in the world in India, about 1,000 years old. 2,000 years old. Rajaraja Chola built it across Kaveri in 1st century or 3rd century. Okay, just very close to Tiruchirappalli, okay, across Kaveri. Even today it exists. It is completely done using granite, no cement. Granite was been carved, and which is with grooves. They have been put together. Please, if you have if you have a chance to go there, see this dam. This is one of the oldest dam India has constructed. And also look at the dams which are constructed during Harshavardhana. All that is earth dams. They are actually live longer than concrete dams. So we need to look at, there are fantastic technological solutions, whether it is underground dams or above ground dams or storage structures, because now, with these new materials, you can filter them. So erosion can be reduced. Okay, erosion can be reduced. So geofabric can be used, geosynthetic can be used. So there is mind-boggling. The design in using geosynthetics is your imagination. Innovation can happen every step using geosynthetics.
Yes, Yeah, that is very true. Actually, we see that in Northeast as well, that a lot of interventions are happening, but not changing the course of the river or anything of that kind. I would also like to request Professor Sharma to respond to one of the question, which I think, which is related to urban floods in Assam. So, you know, what is your view on this, as we see that this floods happens almost every year, maybe even, in fact, more than a year? And what kind of diplomacy do you see there?
So for urban flood is concerned, that is basically that is happening because the drainage system gets choked with the sediment coming in from the hill. Generally, our urban area are located just in the foothills, and that way what is happening because of deforestation, a lot of sediments comes in, then the drains get clogged, and because of deforestation, water volume is also increasing. So that way, that ecological management practice that we were advocating, that has been implemented in some of the pilot watershed here. And this has shown that sediment and water coming in to the local lower level area where the flood is the cause, but the actual, cause is in the hill, but could be controlled to a very significant level. And if this kind of approach, if we take, then also we need to increase the storage in low-lying areas. So that kind of approach needs to be taken. And this is about the urban flood. Most of the area, the drain, we can make perforated drain. The pavement should be changed with perforated pavement. Earth should be made perforated so that we can have better infiltration. This is one. And also your one point regarding hydro diplomacy, that I would like to address one point. Suppose managing any water, I mean, not only water scarcity, but then flood and all these things, if we take together, then we can always plan in a much better way if we think holistically and in an integrated manner. And in this case, only important way for managing the water in a much better way. But then river catchment, we need to take the river catchment in that case. But the river catchment do not follow our territorial boundary. So generally all rivers are flowing to either different country or in India, south, suppose different states. So there we need to make the plan in a way so that the upper riparian and lower riparian all get the benefit. And so the planning needs to be made like this, and then this plan becomes riparian as well as lower riparian people. So not only in urban sector, but everywhere as a whole. So that's what in brief I want to say, because already is 4:35. So I do not know how much time you have. Thank you.
Yeah, thank you, Professor Sharma. Just one last question, actually, to both of you, which is about, you know, this whole climate risk. This is a question for the audience, and also, you know, we are also working on it. Like Professor Sitharam, you had very nicely showed this example that came from the Netherlands, and this was planned so many years back. Do you think that in India, the institutions or even those who are involved in developing infrastructure actually keep in mind the impact of climate change and how these infrastructures will be, you know, facing severe problems in say 50 years down the line? Do we really do such planning? Do we really create scenarios and create our infrastructure, bringing in the uncertainties that may come in the near future?
See, as I told you, we should actually, what the decision we made in 1960s to build large dams, maybe that time it was good. First, we should stop building large dams. I mean, I'm very sorry to say this, but the whole world has stopped. Okay, if you look at, go to the world body of large dams, look at how many dams have been constructed. No other country, by 2000 itself, they have stopped constructing large dams. So we should also stop. That is number one. At least we should not take up the new ones which we are still considering. So we should look at smaller, beautiful solutions, okay, local solutions through hydro diplomacy. And one is groundwater. See, I saw one answer by one of the other expert, Professor Basant Maheshwari, in the audience. I saw the chart. He has done fantastically, he has told. The kind of work what he is doing involving the local people to manage groundwater and also understand about what is available, who is the owner of that groundwater is very key for survival of that water. Okay, so I think, you know, there are fantastic solutions available, and I think there are fantastic expertise also available. And as I told you, we should actually maybe erase the newer things what we are practicing and go back to the old time of small and beautiful, and still we can survive. And you have to do for the urban, solutions will be different for urban, and solutions will be different for rural, and solutions we have to use the technology as well, like geosynthetics in many places, and see what is best with a discussion, deliberations, okay, what we call deliberative democracy, and bring it. I think India has learned over a period of time, and there are fantastic examples also created, whether it is river rejuvenation or underground groundwater storage, or some of the catchment areas, you know, or rejuvenation of entire Saraswati river, okay, in the Rajasthan. There are classical examples that we can do, but we have to do much more and more now of that kind, rather than resorting to large dams.
Thank you. Professor Sharma, would you like to add something to it?
Yes, that is very true. In fact, that is by involvement of the participation of the people is extremely important. And when we are talking about is the people, participation of the people. And we have developed some concept of rainwater harvesting, which is also aiding the groundwater infiltration. And this concept has been already attained by some local people as well as some trigger dams. So they are getting immense benefit solving their waterlogging problem. Their even microclimate change has happened. Their temperature has come down in that area with the pond system and the infiltration well. So that kind of solution can provide very easy, and at the local scale we can have the solution. So that kind of practice are necessary. Yes, thank you.
Okay.
I have one suggestion to you.
Sure, sure.
You had conducted very fantastic lectures over a last 2.5 months. Okay, I think you should record this, in the sense not just recording on the video. You should transcribe them, because very easy with technology. If you did not know, IIT ACB Center in Bangalore have also given such webinars. They have actually brought out first series of 10 lectures, a PDF file. Okay, what they did is they translated this video lectures which recorded in Zoom to the text form and inserted the presentation material here and there, and created a document, and they have released the first volume of 10 lectures, where actually I gave the first talk on water there at IIT ACB Center in Bangalore. You can Google IIT ACB Center and go to their webpage and see. And I think similar effort can be done. Another one is all these lectures also can be placed. See what happens in large videos, many of them will not watch. If there is a text material, we'll just glance through very quickly. Okay, that is why I said putting it in a PDF form, it will always be better. So this is my suggestion to you.
Sure, sure. That's a very, very good suggestion. We'll definitely do that, sir. So thank you very much. And I also have to tell you that thank you for all your support. We have asked you to come several times in this webinar series, and in spite of being busy, you have always joined us. So thank you to both of you for the excellent presentation today. And I would also like to thank all the participants who are observing this and have followed us in all the webinar series. So thank you very much. If we start the second series, we will invite you back again. Thank you.
Bye-bye.